Good day, everybody. How are you all? Today we are going to talk about correlation. So I'll share my screen with you. Hmm. So correlation means together relationship between two variables like X and Y. As you know, a variable is a number that can vary all over the place, such as a person's height. How is the height correlated or related together with the weight? So weight may be on Y and height may be on X. Okay. So what is the correlation between X and Y? Okay. So bivariate data means two variable data. The example I gave, height and weight. Height is on the horizontal axis, weight on the vertical axis. Suppose that a real estate agent wants to study the relationship between the size of a house and its selling price. It is reasonable to suspect that selling price is related to the size of the house. Specifically, we expect that houses with larger sizes are more likely to have higher selling prices. A good way to visualize a relationship like this is with a scatter plot. In a scatter plot, each individual in the dataset contributes an ordered pair of numbers, and each ordered pair is plotted on a set of axes. What it means is that we will have a data set of X and corresponding Y, and in a scatter plot, we will plot these individual pair data points which consist of one set of X and Y. So there will be many points scattered all over the X and Y plane, as you will see. So here is an example. The following table presents the size in square feet and the selling price in thousands of dollars for a sample of houses in a suburban Denver neighborhood. Construct a scatter plot for the data. So X is the size and Y is the selling price. Why is it so? Because you know selling price Y depends. It's a dependent variable that depends on the size of the house, which is X, which is the independent variable. So always the independent variable is on the horizontal axis or X axis, and the dependent variable, which depends on X, is on the vertical axis. So we have a set of data which consists of several X and corresponding Y, or X and Y paired data points. Can we make a scatter plot like this? Sure, we can. So first thing we will do is we'll take our TI-84 and clear the memories of the calculator. We don't want any leftover data in the calculator to influence our calculation. How do we do that? We press the second button on the top left, then the plus button on the bottom right of the calculator, please. So second and then plus, and then number 4, which is clear all list. And then again hit enter. Done. Okay. So that means memory is clear. Now stat and 1. So in L1, we are going to plot the sizes of the house: 2521, 2555, 2735, 2846, 3028, 3049, 3198, and again 3198. So we entered all the X values on the inside the L1. L1 stands for list 1 of the calculator. At the end of L1, when we finished entering the last data X value, 3198, our cursor or the black rectangle sits below 3198. Now we press the right cursor key on the top right of the calculator, and it will now come to the first line in L2, where we will enter the corresponding Y values which start from 400 in the second column of the data, as you see. So first value on L2 is 400, then 426, then 428, then 435, then 469, then 475, 488, 455. So we have entered all the X and Y data pairs. Now we are ready to make the scatter plot. Before we do that, let's press Y equal to key on the top left row, Y equal to key, and make sure on the right of the equal to sign, you will see y1 equal to, when you press y equal to, you will see y1 equal to, y2 equal to. There should not be anything on the right of any of these equal to signs. On the right, it should be empty. So you can scroll down to y0, not y10, and see everything is empty on the right of the equal to sign. Then you press second button on the top left, and then y equal to. Then press number 1, that is your selecting plot 1. Okay. And the first line flashing should be on. The second line type should be on a scatter plot, which is the first one. So in the second line, bring the cursor on the first type of plot, which is a scatter plot, flashing rectangle, put it on the first type of chart and hit enter so that it keeps flashing on the first type of chart, which is a scatter plot. Your X list, next line should be L1. Your Y list, automatically it should be L2. If it is not L2, then you will press the second, bring the cursor on the right of the Y list after the colon, and then press second and 2. It should be now L2. So X list is L1, Y list is L2. How will you see the scatter plot? Press the zoom button, which is the third key on the top row, and 9, zoom 9. And you will see the scatter plot going up the hill just like it. Notice as X increases, Y also increases. That's why we are climbing up the hill. That means there's a positive relationship between X and Y. Why? As X increases, Y increases. X decreases, Y also decreases. So they show you how to do it with TI-84. So as I said, there's a positive association between size and selling price. What does it mean? If you follow the arrows, horizontal arrow on the bottom, it goes to the right, and at the same time, Y increases. You go up from small values of Y to the high values of Y. Plain English, it means as X increases, Y increases. And vice versa on the blue horizontal arrow on the top, as X decreases, Y also decreases. The blue vertical arrow points down. So we say there's a positive linear association. Why do we say linear? Linear comes from the word line. It means, as you can see, all the points, these data points are clustered around a straight line. Hence the word linear, positive linear association. That means the points are clustered around a straight line with a positive slope. That means going up the hill. Two variables are positively associated if large values of one variable are associated with large values of another. Two variables are negatively associated if large values of one variable are associated with small values. As X increases, Y decreases, as in the second chart on the bottom. Two variables have a linear relationship if the data tends to cluster around a straight line when plotted on a scatter plot. If large values of one variable are associated with small values, then the two variables have a negative association. If two variables have a positive association, then large values of one variable are associated with large values of the other. If the points on the scatter plot tend to be clustered on a straight line, the variable plotted have a linear. Linear comes from the word line if they're clustered around a straight line. Okay, for each of the following scatter plots, state the type of association that is exhibited. A, going down the hill, positive, negative linear. As X increases, Y decreases. A. Part B, it's not a straight line, it's curved. So it's positive, non-linear. As X increases, Y increases. How about part C? All the points fall on a straight line going up the hill, close to a straight line, clustered around a straight line. So it is a positive linear. How about D? There is not a good relationship. It's a weak linear. Why? Too much scatter on the data. And how about E? Going down the hill, but it is curved. So it's a negative non-linear between X and Y. compute the correlation coefficient. What is correlation coefficient? It shows us the strength of the relationship between X and Y. Okay. A numerical measure of the strength of the linear relationship between two variables is called the correlation coefficient. This is the formula. Let me briefly tell you what's happening in this formula. First, you see that uh, capital M sideways, it's Greek capital S or sigma, which means you sum up. What are you summing? Product of two quantities. What is the first parenthesis quantity? It is the standard normal score of X value. Zx is the first parenthesis, standard normal values. From each value of X, you're subtracting the mean divided by standard deviation. So it is the Z score for each X value. That's in the first parenthesis. The second parenthesis is Z score for each Y value. So Z score of X multiplied by Z score of the corresponding Y. So it's a product, Zx times Zy. You find out Zx times Zy for all the data points, the product, and then you sum the products and divide by the sample size minus 1. Okay, that is what it is happening. Do I have to memorize this formula? No. How will I calculate it? With the calculator. I will show you in a minute. Okay, the correlation coefficient is always between minus 1 and 1. And that is the lowest value of R is minus 1, the highest value is positive 1. The correlation coefficient does not depend on the unit of the variables. It does not matter which variable is X and which is Y. The correlation coefficient only measures the strength of the linear relationship. It can be misleading when the relationship is nonlinear. The correlation coefficient is sensitive to outliers and can be misleading when outliers are present. Remember, outliers are numbers which are far away from the rest. What they're saying in the last bullet, so if there are too many outliers, the correlation coefficient is misleading and will not give us correct picture. So how to calculate the R value of this uh, data set that we have in our calculator? In L1, we have X, L2, we have Y. We are not going to use the formula, so don't worry about it. So first, you put the calculator on, okay? Press second and 0, okay? And scroll down. Scroll down, you first see A, B, then C, and then D, as in David. Okay, keep scrolling down. Let's see what we can do. Coordinate of cosine, cosine. C, we keep scrolling down. D, we are scrolling down. Okay. So there's a cursor on the left of D. Bring the cursor, align the cursor, that is the arrow, with diagnostic on and hit enter. So what did I do? Second button, 0, then I scroll down till I align the cursor, the arrow, with diagnostic on and hit enter. So on my calculator screen, next I will see is diagnostic on and I will hit enter again. That will say done. Now the diagnostic is on. Okay. So how to calculate the R? The R value is given by this 0.900. We should also get it. So we press the stat button, highlight calc on the top row, then number 4, linear regression. Stat, highlight calc means move the cursor on the top row to calc and then select number 4, which is linear regression AX plus B. X list is L1, Y list is L2, and go down to calculate. Bring the cursor on top of calculate and hit enter. And at the bottom of the screen, you see R, which is the correlation coefficient. Notice it is positive. There's no negative sign. That means, and 0.9 is close to 1. Strong, positive, linear association between X and Y. Okay. If R is positive, the two values have a positive linear association. If R is negative, the two variables have a negative linear association. If R is close to 0, the linear association is weak. The closer R is to 1, the more strongly positive the linear association is. The closer R is to -1, the more strongly negative the linear association is. If R equal to 1, the points lie exactly on the straight line with positive slope. In other words, the variables have a perfect positive linear association. Similarly, R is equal to -1, then the points lie exactly on a straight line with a negative slope. In other words, the variables have a perfect negative relation. When two variables are not linearly related, the correlation coefficient does not provide a reliable description of the relationship between the variables. A statistic is resistant if its value is not affected by extreme value, large or small, in the data set. The correlation coefficient, that is R, is not resistant. What does it mean? If you have too many large values or too many small values, that will affect the magnitude of R. How do you prove that? So on the vertical axis in this diagram, they have plotted farmland. And in the horizontal axis, they have plotted area. So they selected some states and plotted its area on the x-axis versus its farmland. Notice all the areas, of course, not farmland, right? And look at Alaska, for example. It has large area, but very small amount of it is farmland. The plot shows the farmland versus total land area. Farmland versus land area. Farmland is on y-axis dependent variable and total area is on the x-axis independent variable. Alaska is outlier. Because of the outlier, the correlation coefficient of this plot is -0.199 because of Alaska going down the hill, but it is an outlier, which is misleading. If the outlier is removed, that is, you remove Alaska, then the correlation coefficient becomes 0.71. Okay. So what do we do if we have outliers? The rule of thumb, remove the outlier and redo the calculation for R. For which of the following scatter plots is correlation coefficient appropriate summary? Part A is good. Part B is not good because it's uh, non-linear. And part C is also not good because there are some outliers in part C. Understand that correlation is not the same as causation. So two variables, X and Y, may be correlated. That means there is a relationship between them. But that does not mean X causes Y to happen or Y causes X to happen. So a group of elementary school children took a vocabulary test. It turns out that children with larger shoe sizes tend to get higher score on tests, and those with smaller shoe sizes tended to get lower scores. As a result, there was a large positive correlation between vocabulary and shoe size. Larger shoe size, higher vocabulary. Strong positive relationship between vocabulary and shoe size. Does this mean that learning new words causes one's feet to grow, or that growing feet causes one's vocabulary to increase? The fact that shoe size and vocabulary are correlated, means there's a strong relationship between them, does not mean that changing one variable will cause others to change. Correlation is not the same as causation. In general, when two variables are correlated, that means there's a strong relationship between them. We cannot conclude that changing one variable will cause the change in the value of other. Bottom line, correlation is not the same as causation. Okay, an economist discovers that over the past several years, both the salaries of US college professors and the amount of beer consumed in the United States have gone up. Thus, there is a positive correlation between average salary of college professors and the amount of beer consumed. There's a positive correlation between average salary of professors. As it goes up, beer consumption goes up. The economist concludes that the increase in beer consumption must be caused by professors spending their additional money on beer. Explain why this conclusion is not necessarily true. It does not mean that increase in salary, professor salary, causes beer consumption to go up. Just there is a correlation between X and Y. X in this case is professor's salary and Y in this case is beer consumption. Okay, so we discussed all this. And I will stop here today. If you have any question, comments, please write me a note. Please definitely write a comment. If you like this video, please give me a thumbs up. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button on the bottom right corner and let YouTube know that you would like to be notified every time I upload a new video. In my channel, I've solved all kinds of math problems just for you. So please subscribe to my channel and take a look at all videos. And do not forget, please do not forget to watch me tomorrow when I'll be back with another topic, another video, another topic. Thanks for watching. Take care. Have a nice day. See you next time. Take care.